Now that we have some context around our building proposal, it's time to get started on mining some data for what the design is going to do. And early on, all of this data is very much relevant in terms of proportional examples to itself. They might not be um, 100% precise in terms of dollar values at this phase in the game, in terms of when I'm starting to look at energy analysis ideas. So I'm always really careful in terms of what I'm going to show a client. It's more of a cause and effect kind of building that I start doing in terms of showing um, not so much this building is going to cost exactly this much to run, because at this point I don't really have any specific design coming together. I'm just trying to mine data, but at the same time I want to start showing this data to the client so they can start being a part of making decisions in terms of how much glazing we're going to put on these two sides that are obviously very important street front property. Everything in terms of energy design begins to become a little bit about compromise. Do I have all glass along the south edge that's going to get sort of beat up by the sunlight? Or do I find the right way to minimize the amount of glass while maximizing visual exposure? And compromise in terms of those types of things are not bad words, and they're absolutely, in my opinion, something the client should be involved in. The better educated the client, the better decisions we can make all the way across the board. And the higher we elevate our status in terms of being experts. So at times, even if these are numbers that you know and things are going to behave exactly as you predict, I find it to be incredibly important to share this data with clients so that they can see the level of effort that we continue to put in terms of building our expertise and our value. So that said, really simple design because I don't know what I'm doing yet. I'm going to sketch out my buildable area. I'm going to extrude that up 30 feet. And then I need to assign it to levels. Levels, in terms of this massing, is what FormIt is going to look for specifically to send this volume, this cubic volume, to the simulation engine, which is Green Building Studio, and generate what's going to be called inside of FormIt an insight. So I'm going to select everything. That's going to pull up my properties panel right here. I'm going to give it a name, proposed design. And I'm going to turn on use levels. And I'm going to make sure that that is set to a layer of proposed building as well. Let's go ahead and actually generate that layer. Edit name, proposed building. Back to properties, and let's set that on the proposed building layer. So from here, starting the simulation process is pretty simple. I've got my levels selected, and I only have two levels in this case, 0 and 15 feet. Both of them are reading. On occasion, you'll notice like a level 1 might not give you any square footage. Come back and verify that your building is sitting on the ground plane or at elevation 0, 0. It's a really important thing to check because these numbers are what is going to be used in the simulation. The area, the volume of this, so my cubic volume combined with the floor area, is what's going to drive a lot of the numbers in the simulation. So creating that simulation is pretty simple. Make sure you're logged in. Go to Generate Insight. And that's going to upload this geometry. And essentially then it's going to start cooking in the cloud. And while that's happening, I'm going to do a few other pieces of information as well. The first one is a little bit of solar analysis work. So to do that, I'm going to go to the Sun tool set, and I'm going to activate solar analysis. So on the solar analysis, I can simply select what surfaces I want to have the solar analysis done on, or what I typically do is I want all of them. So I'm going to select all of the surfaces just by a double click and run Analyze. This is going to give me the basic solar analysis in terms of BTUs per square foot on a surface. And from this point, I want sort of this raw data so that I can do some comparisons later on. I have two options I can look at. I can look year cumulative, and this gives me an idea, in particular, if I'm going to do solar panels or something like that. I can understand strategic locations to place those, what surfaces have the most energy on them in terms of BTUs. For pre-design thinking for me, typically I want to look at month peak. And again, in the Midwest, in an area like Kansas City that has a temperate climate, we have 80 to 90 degree temperature swings throughout the course of a year. So I'm in particular interested in a time like August as a month peak, where I can look at, okay, on this surface, how many BTUs do I have? What exactly am I dealing with when I have a 95-degree day and I also have 151 BTUs per square foot on the surface? How am I going to start dealing with that? On the east side, 145 BTUs. Again, on the east and the west, little bit different scenario, because a lot of times it's going to be much cooler in the morning, so I can be a little less concerned about solar heat gain on this surface. But on the west, where I'm getting into 3 and 4 o'clock, you can say I'm even higher in the value on this surface as the sun's starting to set. So those are all things that I need to be very aware of as a designer, and again, that I want to communicate with the client. And then obviously the roof is, baking. So let's go ahead and capture a few of these. While I was going to say while the energy analysis is forming, but it just finished. So let's go ahead and do a couple of quick exports. Export locally. I'm going to export this image and accept the defaults. I'm pretty fine with those defaults. And I'm just going to say export and a JPEG solar radiation 1. And then let's navigate around to the other side and do the exact same thing. Export locally, export JPEG file, solar radiation 2, and I should probably be putting a dash AUG for August so that I know that that's the peak month for August on something like that as well. I can do the same thing. Let's pull this back to when it's frigid, say January. And I've got that same data here. And so this is a time where I actually want 186 BTUs on the surface to help heat that interior space. And using this as a tool set, I can start to navigate between what kind of shading devices can I put on to actually help generate a little bit. What kind of overhang do I need and what kind of density? I know it's going to cut some of the gain, but how can I work with a surface that is going to help sort of find the right balance? So same thing right here, file, export locally, export JPEG file, and let's call this solar radiation 3, and that will be in the month of, what was I in, January, I believe, and save. So the next thing that I want to look at is actually not available in the Windows version, just simply by how it plays out, but is available on the FormIt version online. So let's pull the online version of the exact same file in. If I go to the location tabs, or the location tool set, in the 360 version, I've got these great little weather stations that I can pull up. And if I select a local weather station, so this is my site location, I'm going to pick the one that's closest to, or that I feel like has a similar set of variables around it. So, I wouldn't want to pick one that's, say, on the Missouri River here, because that might have a pretty distinct difference in terms of the microclimate, how wind might be moving along the river or through this valley, as opposed to something that is a similar urban condition. So I'm going to select that weather station, and I have a couple of wind roses now that I can pull up. So this is the annual wind rose, which again is great if you're not in a temperate climate. If you're in a climate where the temperature is swinging by a radical amount, then I know there are times of year I need to block wind, and there are times of year where I might be able to capture wind. If I come back in, select that weather station again, and look at the December through February wind rose, I know this is wind that I need to block. And unfortunately, it's coming primarily from everywhere, but sort of the strongest, most vile bits of wind are coming south-southwest and north-northwest. So this sort of north-south wind that's sort of blasting the site. And so if I can work the building to help block that, especially when we think about entries into buildings, that might be really, really to my advantage. And so again, this is something that typically I would capture just using print screen. And then we can also look at March through May, where the wind is predominantly from the south and a little bit from the southwest, and think, okay, that same direction, but I wonder if there's a way that I can kind of scoop that wind into the building and see if I can't leverage that to help condition the building at a few times of the year, where I might have a temperature range where I can actually use a little bit of natural ventilation. Same thing with the September to November. So in a lot of locations, you'll see sort of these swings in the wind direction that might actually be something to your advantage. A little bit less here in Kansas City, but definitely a little bit of wind coming predominantly from the east. So we might get to sort of this east-west movement of some of the breezes at certain times of the year in the fall that we could really take advantage of. So let's go back into FormIt. And I know that Insight was done. So we'll go ahead and close the solar analysis. And we will go to View Insight. So on our Insight, again, at this level, we're very, very diagrammatic, and that's okay. That's what we want to work with. I know that there's really not much I can do or need to do right now with the building orientation. I'm on an urban site, and I am locked into my footprint. But there are certainly things that I can take to my advantage or use to my advantage. And let's start with the southern walls, as I know that's one of the larger areas of exposure. So I can flip these tiles over, and I can look at what type of glass or how much glass I'm going to have on each of those surfaces. So I can do that simply by narrowing down how much glass I'm going to have, and that's going to have a direct impact on the amount of energy used. By doing that, let's close this, it's going to update this model, and you can see it's actually closed off the amount of glazing on that side as opposed to the others. And I can continue doing that. Let's go through and also look, and it's interesting to note as well, the difference on that south side, the amount of glass doesn't have as large of a variable as the type of glass. So if we look at a triple OE, we're actually beginning to have a little bit better of an impact overall. And then also if we begin to have a little bit of solar shading, we can start to work with that number as well in terms of a reduction on the energy. Let's go ahead and close that. Next, I know on my north wall, I don't have any glass at all. So we'll take that all the way down to 0. So I don't need to worry about any of these. On the east and west, we're going to have maybe about 40%. So essentially what we're doing in this process is we are working through establishing some baseline averages that our building and building simulation can start to respond to. And again, as always, the goal on something like this is working with numbers, working with, can we get our costs, our energy costs, down to an acceptable standard for the future. In particular, we're looking at numbers for the 2030 challenge, where we're trying to cut building costs, and we're trying to improve building performance by certain standards. So given that, and working through this is a great opportunity to begin to understand early on what impact doing certain types of constructions, certain quantities of things like glazing, certain wall types, again, looking at how much insulation and wall construction types and roof construction types. We can see massive savings, this major drop off by going to an R60 roof type. just by doing that. And again, in an area where there's larger temperature swings, we know that's behaving as expected. But again, that's a really important piece of data to communicate.